And my computer clock says 9:21, which is 9 minutes. So we are aligned there.
All right. Make sure I got everything right on my end.
How many of these are you doing this week?
I got 3 today, and then I'm actually up in Jersey, but I live a little west of Fort Worth, so I'm headed back. I head back in the morning.
Very good.
Where are you at, Mike?
Franklin, Tennessee.
Okay.
I'm doing a public training certification class from a community college here in Franklin. And yesterday, the AV system went haywire on us. So that's why I made the video last night. Got to have a backup plan in case it goes haywire again.
All right. I'm good there. Yeah, hopefully it runs smoothly.
Any idea how many folks have registered for this particular session?
I don't know by session. Sonia had never told me that. I do know, I think we've got like a little over 100 registered for the whole thing.
Very good.
You said you're in Franklin, Tennessee?
Due south of Nashville.
Okay.
Or
Franklin's the nice area, right?
It is a very nice area. Good place to live. In a county with good schools and multi-generational families, and it's nice.
Yeah, I know that's a big it's been a big destination. Well, a lot of the, obviously the celebrities and everything that have come out there, I think, gravitate towards. Is that Franklin County or is it just Franklin?
Williamson County, Brentwood and Franklin, Tennessee, and Williamson County.
Okay.
Yeah, so it's kind of odd seeing somebody you expect to see on the stage wandering around Home Depot.
Yeah.
And the best thing just to let them wander around and ignore them, because good and well they don't want to be accosted for a signature.
Yeah, very true. We've got a bunch of Bollywood people moving out around where I'm at, Parker County, but a lot of the California horse people coming out there, so it's been interesting.
Trying to get out of the idiot state.
Yeah. We got Taylor Sheridan too, the guy that did Yellowstone. He just moved probably about 20 minutes from where I am, and he's brought a lot of that with him. So yeah.
I don't blame him. I wouldn't want to live out there in that craziness either.
Yeah. So what do you do day to day?
There's 2 companies here. AMRRI provides engineering services and education in machine reliability. We focus almost exclusively on machine lubrication, work planning practices, development, and execution. And then there's another company, Generation Systems, that publishes a work management software solution called Lubit. That's a 30-year-old company. We purchased that just before COVID hit us. So the work planning, the practices development fits nicely into the work management side of the business. So if somebody is looking to make improvements, then we can offer them the means to do task management, build the practice, build the program, spin it up into existence, and then train their people. And it's all kind of a holistic thing. And we also publish a web magazine that Greg contributes to, actually. That's a Precision Lubrication web magazine. So
very
just
cool.
enough to keep us busy about 70 hours of every week.
Yeah, that's plenty. Hope that's collectively, not just you.
Yeah, well, when I get to the point where I spent too many hours, too many weeks in a row, I can feel my attitude declining, and I need to go soak my head in the lake. So I do take advantage of that.
Yeah. Did you do any of these last year?
Yes.
Okay.
I can't tell you I remember what I talked about, but I did do a session last year. You know, hopefully I won't screw it up this year. Didn't screw it up last year. Should go fine.
Yeah, I think you'd be fine.
My phone says 9:27. Okay, my computer now says 9:27 too. We start right at 9:30, right on the nose.
Yeah, you want to?
I'm following your protocol, whatever you
Oh,
guys.
absolutely. Yeah, no, I'm the punctual type, so we'll go right at it's 10:30 my time, but 9:30 your time, yeah. I think we're the first one of the day too, so
Are we really? Huh. Is this day one?
yeah. Well, it's a 1 day. So what they did this year is they split it up. They actually did 3 of them globally. So we're only doing 1 day in the US. And I might be lying. There might have been one before this, but earliest one I know of. So
Okay. Y'all do know I'm going to be another 30 minutes, right? Okay, very good. Just want to make sure. Did I expand this Zoom webinar screen to full screen?
I believe you can. There's a full screen mode.
I just want to check if you,
What?
hey, Mike, I just want to check. If you do the other settings. Everyone, oh, beautiful. Look at you do.
Yeah,
You're set.
he's surprised because I did it correctly.
I know.
You did it right.
I'm one of the few tech savvy guys in the company, so I'm thrilled.
It's like,
All right,
oh,
good
wow,
luck,
it's
y'all.
right.
Yeah.
Oh, you got it right. Imagine that. That's the second time.
Yeah. Yeah, it's funny. Oh. Yeah, what I'll do, it's at 9:29 your time right now. So I'll run through the introduction and then I'll turn my video off, turn it over to you, and I'll be sitting here watching. If you have any technical difficulties, then just give your screen up. I'll take over and I'll play your video.
Okay, very good. Thank you.
All right. Good morning, everybody. Let's welcome our next speaker, Mike Johnson. He's the president of AMRRI, as he talks about how to create and deploy effective reliability-centered lubrication work practices. Take it away, Mike.
Thank you, sir. And thank you to the audience. I do appreciate the opportunity to share this presentation with you. Is our audio okay, James?
Audio is good.
All right, here we go then. So this presentation is about how to create and deploy reliability-centered work practices. I have this Zoom quit unexpectedly thing showing up again, James. Proceed as long as we can.
So it's all good right now, assuming your slides are working fine, but you're on full screen and it looks good. Hey, Mike, that's fine. Let's I'll share my screen and I'll take it away. So Mike's having some technical difficulties, so we're gonna do, he pre-recorded, kind of anticipating this. So I'm gonna go ahead and start his presentation from my end.
Hi, this is Mike Johnson. I'm pleased to be able to offer today a presentation for how to create and execute reliability-centered lubrication work plans to improve the reliability of overall asset performance. You go ahead and turn my presentation on here. If you have any questions, I'd certainly love to hear from you. My email address is mike.johnson@amri.com. It has been said that the industrial world floats on a 10-micron film of oil. Well, we only wish we were so lucky. The hard reality is, for all of our rolling contacts, such as element bearings and any other machine that experiences rolling contact, the reality is our oil film is somewhere between 1/2 and 1.5 microns thick when those components are under load and operating. Journal bearings and all other sliding surface interactions are relatively luxurious 3 to 10 microns thick. The reality is most of our machines operate on an oil film that's the thickness of a red blood cell. Now, while it does work, it is still a precarious thin layer of protection. We build work plans to provide a continuous replenishment of this red blood cell thick layer of protection to our machine surfaces. Our attempt is to provide a continuous coating of new or healthy, clean, fresh oil that cushions and seals components to prevent wear and corrosion. When we aren't able to do that, we recognize that we see wear from surface rubbing, wear from contamination, wear from fatigue and corrosion, all of which produces lost production time. And it doesn't really matter whether the production time is scheduled or the repair time is scheduled or unscheduled. Once it's gone, and we cannot get it back. Loss of machine repeatability, that may have the potential to impact product quality control. Increased risk of injury. We do know from our own experiences that as personnel are busy scurrying around trying to make machine repairs in a rushed fashion, that the risk of injury increases. All of this produces higher product cost per ton, per unit, for whatever our production increment is. And of course, that means loss of competitive position for our company, for our business unit. These failure modes that we're talking about are all measurable, predictable, and avoidable failure modes. So with everything that we have that we need to address on a day in, day out basis, why would we bother investing resources, including time and money, into better lubrication work plans and execution? Reliability-centered lubrication holds the promise for us of substantial reductions in the needed replacement of lubricated machine parts. And we should target for a 25% reduction at a very minimum, with a target of 50% reduction in replacement of lubricated machine parts over a 3-year period from implementation of an aggressive reliability center plan. That also includes all the labor associated with those mechanical repairs, and certainly would include any contract labor associated with those mechanical repairs, including for planned and unplanned outage requirements. Obviously, we're interested in increasing the net production output, and the real reward for our efforts would be the means to have more production, more output from the facility without spending more capital than brand new machinery. And if you look around at your production site and you look at the experience that you have on a day in, day out basis, you have to beg the question, Is this what I want? Is this acceptable? The system that you have now is perfectly designed to give you the results that you get right now. And upon answering that question, is this what I want? Is this as good as we can do? If you don't like the answer, if you don't like the results you get today, well, you need another system. You have to have a different system. So there are steps that we can follow to create and deploy reliability-centered lubrication work plans that will help us reduce the helter-skelter busyness of our production environment by eliminating the need to replace lubricated machine parts. There are several steps. We'll follow those steps here as we go through this production, and we'll address each one of them one at a time. Create a floor plan that provides the machine location for each operating asset. Create a route based upon that floor plan that gives us the means to offer our workmen an efficient linear sequence for completing the work practices. Record the machine information in that route sequence, including all of the relevant details: machine name, number, the component types, the component names and numbers and nameplate details that define what the component requires for long-term health, any environmental influences. And then with that information, we create rules-based lubrication tasks. We organize those tasks in the efficient sequence that we have defined based upon that floor plan we created in step 1. We drop the tasks into a task management system. We're interested in managing, that is scheduling, tracking to completion, and reporting on every task that we have for every machine that we believe justifies long-term care. Conventional CMMS programs are fantastic. They do amazing things, but they're not very good at keeping track of the tens to hundreds of thousands of tasks that we may need to track in a large production facility. We want to run weekly schedules so we can remain very close to task completion. And then we want to measure and report out our key performance indicators of the state of our program, again, on a weekly basis. So let's look at these things one at a time, starting with the floor plan. When we engage with a customer to help them improve their work practices, we start by looking to create a floor plan. The floor plan represents the entire production unit, as big as it may be. That includes walls, tanks, stairwells, motor control rooms, and other non-rotating assets or features of the production facility, maybe a stairwell or elevator here and there. And then once we have the floor plan defined, we're going to go back into that area and plot the location of all of the machines that are in operation. Now, this is very important for a couple reasons. Number one, we need to make sure that we have the accurate name and number for every asset on the production floor. Number two, we need to make sure that we have accounted for all of the assets that are necessary to maintain production. And then number three, it gives us the means to look at the location of all assets relative to one another so that we can generate a route that represents the most efficient pathway for the workmen to follow to get to all of the assets in a timely manner on the production floor. We may have some very complex machines that are sprinkled around within their production department, and the same thing applies to very complex machines. This would be a machine with multiple drivetrains. We need to account for each and every drivetrain for the complex assembly, and then once again come up with a linear sequence that represents the means to cover all of those machine parts each time we issue a route related to those parts. Number two, create the route. Now that we have a floor plan, we want to sit down with maintenance and operations and lubrication technicians and other personnel and plot out the linear sequence that represents the most efficient pathway from one end of the production site, the production department, to the other. We need to get the engagement of the persons that must deliver this work so that it is their route, not our route. we don't get the engagement from the technicians, then there's going to be difficulty getting this work plan deployed effectively. Number three, now that we have locations of machines in a linear sequence, we want to return to those machines in that linear sequence, in that route, and record all of the relevant machine information that's needed to build a work plan. For our part, we use tools to help expedite and clarify this. This is a simple form that technicians will follow to fill out to gather all of the needed information, and then we can drop those details into a computer program to help organize our work such that we end up with very specific tasks for each and every component on each and every machine. That includes the product type that's defined and validated, the frequency for running work practices plans servicing the machines, the volumes and the frequencies should have an influence based upon the relative degree of difficulty of the operating environment. There's certainly calculations that need to be done in order to give us the means to validate the work practices, plans, and expectations. There's rules or guidelines for all of our machine operating components. Considering an element bearing, there's rules related to validating the operating viscosity of the element bearing, whatever kind of element bearing it is. And it's a very straightforward calculation. So we can calculate the value, we multiply that drop dead limit by 3. We set that as a target for our product selection, and the alternative is, we don't like calculators, we can always plot that on a chart provided by the lubricant manufacturers, the bearing manufacturer's guidance. There is a chart that looks a lot like this on all of the bearing manufacturers' lubrication guidelines. So we find that chart, plot the bearing's median diameter against the operating speed, and we can estimate a drop dead value or conversely calculate the drop dead value. There's rules around determining how much lubricant to provide. It's a simple rule. The width times the OD, measuring the bearing width in OD in millimeters, times 0.005 gives us a volume in grams for each replenishment activity. There's rules around determining how often we should be feeding those bearings. And here's an example of a modified DIN formula, DIN standard 51825 part 2, where we have bearing information inside the first set of brackets, a value representing the environmental influences in the unit K that we see here. K is the multiplication of the service factor for bearing temperature, for the contaminant load, for the moisture load, for the vibration or shock loading parameter, for the shaft position, and for the bearing design value. Those 6 elements multiplied together give us K, multiplied by a plug factor 20 gives us an interval in hours that we can then turn into days, weeks, or months. The next thing we do once we have collected the information needed to prepare the tasking, we're going to organize those tasks in an efficient sequence. So the output would look something like this. It's a simple chart that shows 5 machines, motor information, pump information, coupling information. Every lubricated component is identified. Some additional descriptions might be appropriate. The number of each, the unit measure for the lubricant that we're applying, and the number of locations where that lubricant is applied, the method of lubrication, the product type selection that it's been validated through calculation, the component manufacturer, make and model, perhaps, task type, the interval or trigger, whether the machine should be shut down or not to fulfill the work, the route and the sequence for that work to be completed, the duration for each task, and then lastly, a procedure, a written procedure that helps the new workman understand what this task is and how it should be accomplished. So we organize all of our task care details into a linear sequence. The next thing we want to do is drop this set of details into a task tracking type of work management program. There's plenty task tracking programs available to select from. The benefit of the task tracking plan is that we can organize our work according to the production unit utilities, then with each asset within the unit listed, and with each asset showing all of the parts that need to be lubricated and the details related to the work plan. Once we have the database built showing the department and the asset, the tasks that are to be scheduled will show up in a linear sequence. From there, it's a matter of generating weekly schedules, giving that software program the means to push out the tasks that are going to be due during the weekly work period. And we notice from the previous step that we have 24 elements or tasks or components, if you will, in this very small utilities department. We're not going to see all 24 components each and every week. We're only going to see those that are either due, as denoted by the green ball, or overdue, as denoted by the red asterisk. The task tracking system will do a good job of keeping track of the completion status of the task, and if something is left undone in 1 week, it gets automatically pushed to the next. We can print this information out to an electronic tablet, or we can print it to a sheet of paper, including the notation that tells the workman whether something is past due and perhaps how past due it might happen to be. The last step then, once we have deployed the work plan and we are collecting information back from the employees about the fulfillment of the tasks on a week in, week out basis, we want to measure and publish the success that we're having. Measure performance and tie that to stated key performance indicators. Here's 3 reasonably healthy key performance indicators. The task completion percentage as dictated or as produced on a weekly basis. We would like to accomplish fulfillment of 90% of all of our weekly activities. And if a task is left incomplete for whatever reason, and there's often good reasons that we don't fulfill a lubrication task, well, let's record that reason and publish it such that we can figure out how to overcome that obstacle in the future. KPI number 2, when doing oil analysis, the percent of acceptable lab results in any given weekly basis ought to be over 80%. This would be the result coming back from the lab without any kind of an alarm indicator for either oil health or the contaminant load or wear debris types of alarms and limits. KPI number 3, we should get in the habit of tracking the average ISO cleanliness measurement for all of the assets that are under oil-based condition monitoring. And we should set a fairly aggressive target. Brand new oil out of the drum is going to show up at our back door in the neighborhood of a 21/19/17 ISO cleanliness value. This corresponds roughly to 10 parts per million or 10 milligrams per liter of gravimetric value. So it's reasonable to say we don't want the oil in the machine to be any dirtier than the oil that's delivered to the back stoop. And as our program matures, we ought to provide the means through assist filtration or improved onboard filtration to drive that oil to a cleaner and cleaner and cleaner state of existence. All of these steps should follow rules. Determining component-specific lubrication requirements is a job that's based upon rules. There's rules for element and journal bearings predicated upon the math associated with the design of those components. There's rules for couplings. There's rules for gear drives. All lubricated machine part tasking and product validation should follow engineering principles. We don't have time in this presentation to go through those well-defined engineering principles, but they're available in the public domain. The Precision Lubrication webpage could help you find them. The Machine Lubrication webpage can help you find them. STLE, the TLT magazine. There's lots of resources where you can go to follow, to learn about and follow those rules. And if you follow those rules, you will be successful in your efforts. I appreciate the opportunity to make this presentation. Thank you and have a good day.
Hey, everybody. Mike did ask if you had questions, just direct them to him at his email. His email is mike.johnson@AMRRI.com. I posted in the chat box above. So just reach out to him directly if you had any questions specifically over his presentation. Thanks all for your time and thanks for joining.